Here's problem 8.3. A 3 kilogram block is dragged over a rough horizontal surface by a constant force of 16 newtons acting at an angle 37 degrees above the horizontal. The speed of the block increases from 4 meters per second to 6 meters per second and a displacement of 5 meters. What work was done by friction during this displacement? Alright, let's see if we can imagine what's going on here. We got a 3 kilogram block. It's being pulled on by a force, P, which is 16 newtons, acting at an angle of 37 degrees. And it's being pulled on over friction for a distance of 5 meters. So we're going to go from a point A to a point B. And one thing we know about point A and point B is the velocities. We know the velocity at A is 4 meters per second, and the velocity at B is 6 meters per second. So we know we can calculate the kinetic energies at these 2 points. In other words, the kinetic energy at A is 1/2 mass times the velocity at A squared. And that's going to be 1/2 times 3 kilograms times 4 meters per second squared, which will give me 24 joules. And the kinetic energy at B is 1/2 the mass times the velocity at B squared, 1/2 times 3 kilograms times 6 meters per second squared, and that will give me 54 joules. So those are our initial and final kinetic energies. If we were to write down the one equation to rule them all, we would have that the kinetic energy at A plus potential energy at A plus any work done along the way will equal the kinetic energy at B plus the potential energy at B. That's our one equation to rule them all. In this case, we have no springs, so we don't have to worry about spring potential energy. And we're on a level plane. We can define that plane as our zero height. So we have no change in gravitational potential energy. So as far as potential energy goes, we can define them both to be zero because they're on a level plane. So they're gone. Alright? We just calculate the kinetic energy at A. That's 24 joules. Any work done along the way should equal kinetic energy at B, which is 54 joules. Alright, so that's the way our equation looks like right now. Work along the way, there's two works being done in this case. There's a work done by the force P, and there's a work done by friction. So if we were to solve this equation, we would say the work done by friction is 54 minus 24 minus the work done by P. Or in other words, is 30 minus the work done by P. Nice to know. So if I knew what the work done by P was, I would find out the work done by friction. Well, the work done by the force P is the force times distance times the cosine of the angle between the two. In this case, the force is the force done by the force P, which is 16 newtons. The distance is 5 meters. And the angle between the two directions is 37 degrees. So if I calculate that, I get 63.9 joules. So the work done by P is 63.9 joules. The work done by friction is 30 minus 63.9. or a negative 33.9 joules. So that's my answer. Negative 33.9 joules is the work done by friction during this displacement.